Hello students, today we'll be discussing about the JEE mains paper that was conducted in 2017. So here onwards we'll be discussing all the 30 questions one by one, the concepts and the tricks to solve the questions of JEE 2017 mains physics paper. Okay. Hello students, next we move to the next question number 24. The question is a particle A of mass m. Let us say this is a particle A whose mass is m and initial velocity is v. So this is moving with initial velocity v, collides with a particle B of mass, that is a particle over here whose mass is m by 2, which is at rest. So its velocity, so I'll call this initial velocity u1 as v, its initial velocity u2 as 0 because it is at rest. Okay, so this is a situation that two particles are there, one mass is m, another mass is m by 2. This mass is heavier, moving with certain velocity v, it's at rest. Now what happens, the collision is head on. Now it goes and hits this second object. This is the situation before collision. Now I'll draw another picture after collision. So this is the mass m, this is the object A, this is the object B. It is moving, then after collision the velocity will change, and how much that velocity will change, that we don't know. So right, suppose it is v1, the velocity after collision of the first object. For the second object, mass is m by 2, the object is v, its velocity, suppose it becomes v2, it starts moving from rest. Now it is v1 and it's v2. Now the question is, the what type of collision that took place? The collision is head-on and elastic. So from here there is one information, elastic collision. For elastic collision, let me write it here, that for elastic collision E, the coefficient of restitution is 1. This is 1 because from this information elastic collision, so E equals to 1. So we have basically these informations, and the question is to find the ratio of de Broglie wavelengths lambda A to lambda B. So if this is moving, it will have some wavelength associated with it. According to de Broglie, this is called matter wave, and the wavelength is lambda A. For this one, this is lambda B. Obviously, when it starts moving, not now. But then, what is the ratio of lambda A to lambda B after the collision? Because before the collision, this doesn't have any wavelength because it's at rest. So after the collision, suppose that after the collision, the wavelength of this mass is lambda A and wavelength of this mass is lambda B according to de Broglie. Then you have to find the ratio of lambda A by lambda B. So our aim is to find lambda A divided by lambda B, and we have got 4 options. Now we have to have equations. Let me first explain the concepts that we're going to use. Firstly, we can get lambda from de Broglie's wavelength, which is given by lambda is h by mv, that is h by p mv. So in the final case after collision, for this object it will be lambda 1 v1 or lambda a v1. For that object it will be lambda b equals to h by m. Obviously m will also change, m1 v1, and here also is m2 v2. So basically you have to find this v1 and v2. So these are the two unknowns. Okay, so if I don't know the velocities v1 and v2, then I have to use momentum equations also. I have to use another, first you have to use this, then you have to find also p equals to constant. This equation you have to use, momentum conservation equation. And third one is that E equals to 1, coefficient of restitution formula to use is to 1. So first you will use these two equations, and then finally you use this equation and then divide it to get the answer. Let us do that. Momentum equation, momentum before must be equal to momentum after collision. Momentum before, the first object was having mass m, moving with velocity v, so momentum is m into v. The second object is at rest, mass is m by 2, but it is at rest, so it is 0. The second one, then after collision, the mass m is moving with velocity v1. Then the other mass m by 2 is moving with velocity v2. This is our supposition. So from this we have one equation, this m into v equals to m common v1 plus v2 by 2. From this goes, whatever you get is the equation. This is one equation. Then because I have got v1 and v2 two unknowns, so I should have two equations to solve that. That is possible, otherwise the equation solving is not possible. So from coefficient of restitution e equals to 1, that I will use. What is e? E is basically u2 minus u1 by v2 minus v1 and the negative sign. This is the formula for coefficient of restitution. That means this is u1 minus u2, this minus sign goes inside, and this is v2 minus v1. Okay, if I put the value, what was u1? u1 is the initial velocity, the first object which is moving, so that is your v. What is u2? It was 0. Second object, it is obviously v2 and v1, that we don't know. So e equals to, and this equals to 1. If I solve this, then I'll get v equals to v2 minus v1. This is equation number 2. Now this is having v1 v2, this is also having v1 v2, this side is v, this side is also v. If I put this, because I want to write v1 and v2 in terms of the known value, that is v. So I'll do one thing, I'll take v2 as v plus v1. So from here I'll write v2 as v plus v1 and put this in first equation, put this in equation 1. If you substitute this value in equation 1 and rewrite the equation, what you will get? Now let us do that. What you will get? I will get, the first equation was v equals to v1 plus v2 divided by 2. Now I will put v2 as v plus v1. V plus v1 divided by 2. Now if I solve this, this will go to this side, so it is the 2v1 plus v plus v1 equals to 2v. So this v goes to the other side, it will be only v, and this will be 3v1. So v1 equals to v by 3 is first value of velocity. That means after collision, the object of mass m which is moving with the velocity v will have velocity 1/3 of the initial value. Next, once you get this, then you can use any of the equations to get the you can see here, you can use any equations, this or that. Suppose this is a simple equation, I use this, v equals to v2 minus v1. So v equals to v2 minus v1. I'll put v1 as v by 3 over here, this v1 as v by 3, and solve this, bring to the other side of the equation. 1 plus 1 by 3 is 4 by 3, so 4 by 3 v equals to v2. So from here v2 is also 4 by 3 v. This is the value of v2. The other object which is at rest is moving now with this velocity. Then our question is to find the first equation of de Broglie that I told you, that you have to use lambda a by lambda b. Lambda is h by mv, the momentum factor, right? So is inversely proportional to momentum. So I'll write p of b divided by p of a, where p stands for the momentum after collision. This is the obviously the ratios after collisions. Momentum mass is the second mass is m by 2. Its velocity coming out to be 4 by 3v divided by, this is p. A, the first object is mass having mass m and is moving with final velocity v by 3. You can see here this is also 3. So this b by 3, this b by 3 cancels. This m cancels. This 4 by 2 remains, and that is equal to 2:1. That means lambda a upon lambda b comes out to be 2. If I see the question, then lambda a by lambda b is 2 is the equation, the option number 2. You can see here. So therefore this is the correct answer to these questions. Okay, thank you.